Good afternoon. Thanks for joining us for this session of the Device Authority's virtual summit on securing the supply chain and related issues. It's a distinct pleasure to have an opportunity to have Tyler with us today. He's been a friend and a colleague for over 2 decades. And Tyler, good afternoon. Thanks for joining us. Really appreciate you making the time. To kick things off today, it'd be great if you might tell the audience a little bit about yourself and your background and what you do with Device Authority.
Thanks, Khalil. Yeah, and I'm old enough now where being referenced as a friend and colleague for 2 decades doesn't make me feel too badly about myself. So
Hey,
it's all great.
You're still ahead of me.
Right on. Yeah, so my name's Tyler Gannon. I'm the Vice President of Product Marketing and Strategic Alliances at Device Authority. I've been here for about 2.5 years, but I've spent, as Khalil pointed out, over 2 decades in enterprise software and security. Most of that time was with Microsoft. A lot of time in public sector, dealing with enterprise software in medical, in state, local, and federal government, and in higher education. And I'm a tech founder myself, so I actually started a security business, which ended up selling back in 2016 and going back to Microsoft. So security and sort of this topic of zero trust is very near and dear to my heart, and I'm excited to be here to kind of go through it with my colleague Khalil.
Yeah, thank you. So for the audience, we've had some really insightful and wide-ranging presentations today covering the supply chain and sustainability, trends and challenges for smart cities, the importance of device security in establishing data trust, and an in-depth coverage of the growing challenge of vehicle security and related vulnerabilities once we get into that mobile technology environment where you've got thousands of sensors involved. As the closing session for day one of the summit, this discussion turns to figuring out, how do you get to sustainability in achieving zero trust for IoT environments, and how that boils down to automation and scalability as being sort of the chief drivers. Tyler, if you could help us understand the NIST zero trust model, just some background for the audience. And the role of identities in securing IoT environments and machine-based environments that are connected.
Yeah, sure. Thanks, Khalil. And I think zero trust is a term that is in danger of becoming overused. And so sometimes I find it's helpful to kind of actually go back to the source and say what actually is NIST referring to when they talk about zero trust. And so I kind of jokingly call this the long-winded summary. It's not really a summary; it's a full-on abstract.
Yeah.
But I pointed out, I think, some of the language that's really important to understand when you're considering a zero trust approach, because this really was created to move beyond what I think was the concept of a hardened perimeter fence to protect us, right? Everything inside that perimeter is okay. Everything outside is suspect. And we know in this connected world that's not enough anymore, right? So this zero trust framework or architecture that NIST has put forth basically is moving beyond that static network-based approach and looking at the specific things, IoT devices, people, etc., that are asking for permission to access network resources. And I think, if you were in my earlier session that talked about, trustworthy AI, I talked a little bit about sort of this danger of having this implicit trust between an AI or machine learning model
Right.
and the data that it's using.
Right.
And zero trust actually looks at that and says, no, there can't be any implicit trust. It's got to be explicit, because that's the only way we can actually protect ourselves. And so the way that you do that is through the authentication and authorization functions. And ideally, any asset, right, a person, a software application, a device that is trying to connect to the network and ask for resources needs to be authenticated and authorized each session to meet zero trust standards. And that's a monumental challenge, particularly in the IoT world, where you're talking about devices that are numerous, and we'll get to that in a second, and oftentimes outside of your network controls, right? They're out in the wild. They're in
Right, right.
remote locations. They have spotty connectivity, or sometimes intentionally no connectivity for long periods of time. So with zero trust, NIST really wants people to get beyond this concept of the network location being the anchor, and looking at
Okay.
how we can trust things out there. So moving to the next slide. So if you take that a step further, I think it's not too bold of an assertion to say that identity really becomes the foundation of zero trust, because if you don't know what you have and you don't have any way of knowing that over time, you can't actually have explicit trust with a thing trying to connect to you. And this has basically caused the U.S. And the EU to enact legislation or executive orders anyway, saying, you know what, to protect critical infrastructure, zero trust is the benchmark. All right, you can't rely on sort of these older methods for protecting these assets. So if we then say, how do we do that? The foundation for zero trust becomes secure identities. Well, what does secure identities mean? In the world of IoT and devices, it's basically taking AI technologies and using them to create machine identities or non-human identities. Why it's important, and I think there's a couple of data points below this line that I really talk about a lot. For those of you who haven't read the Verizon Data Breach Investigations report, I really encourage you to, because it's actually a great in-depth look at, by industry, by attack type,
Right, right.
what bad actors are doing. And what you quickly find out is that, like, well more than half of them are due to weak credentials. So those bad actors are finding those vulnerabilities in weak passwords, hard coded credentials that come from the manufacturer, and then they're kind of rinse repeat. If they find a device that's vulnerable, they'll go to the next one that looks just like that, and it's probably the same way to get in.
Sort of
So
like the baby monitor problem that people were having with not changing the password.
That's right. That's right. So anyhow, whatever analyst, whatever report you look at, they all point to credentials as being sort of the weakness. So in a zero trust model, we have to look at how we're going to effectively manage those credentials, um, which poses some challenge for security leaders today. Because if I'm looking at meeting zero trust standards for identities, I now have to worry about three different distinct classes of identity. And so you may have seen this slide earlier when our CEO Darren kind of did his overview, or if you've heard me present before, I use this slide a lot. I think humans are one class of identity that everybody's pretty well familiar with. And there are lots of very mature technologies that are very effective at providing authentication and authorization for groups of human users. Machine identities is sort of a new category that's come out in the last few years, and a lot of our partners really focus on machine identities using keys and certificates for things like software applications, servers, APIs, other
Right, right.
non-human and digital assets. But then there's this third category that is sort of an extension of a machine identity, because they're not humans, but they're devices that have a very, very distinctive profile because of the context in which they operate, and the scale at which they operate. And what do I mean by that? If you look at the way traditional identity and access management works for humans, they're kind of logically grouped into these different user groups tied to network resources and easily managed. When we get to IoT identity and access management, oftentimes we're talking about devices that are outside of the network, sometimes offline for long periods of time, not controlled directly by network security controls, and in most cases at a much greater scale than the humans in an organization. In some cases, up to 45 or 50 times the number of humans. So when you start getting to that scale, traditional approaches of managing identities just don't apply. And then you add in the context, which is these are physical things that interact in the physical world, and a breach and a malfunction in one of these has very dire physical consequences. So you have to think about them differently, and it poses a real challenge for security leaders. Now, when we think about zero trust again is an approach, right? It's getting people to think differently about how they're protecting the assets that are connecting to their networks. But it really needs to go hand in hand with another piece of NIST um, thinking, which is the cybersecurity framework. And I think this is something that most people are familiar with as well. But they do go hand in hand, right? They're not mutually exclusive. You have to think about zero trust in the context of every one of these steps in the NIST cybersecurity framework. It starts with identity, but then it goes all the way through to recovering from a breach, which inevitably is going to happen.
Well, thank you for that perspective, Tyler. Staying on the subject for a moment, I think it would be good to understand how important it is to have explicit trust where data exchange, data communications are happening, where information is being relayed from a sensor to another sensor, where you have device to device comms, and one might be a sensor, the other an actuator, where there's a response. And you're outside, or you could be inside a network, you could be outside of a network, but these are devices that are interacting with one another. And in that context, also this notion of, trusting the data that you're seeing because they're actionable data and an actionable analysis coming out of that. If you might talk about that a little bit.
Yeah, well, I'll get to sort of, how you need to think about all this interconnectedness with this CISA zero trust maturity model. But the thing that's important to think about in the context of devices talking to devices, or devices talking to applications,
Right.
or applications using data coming from devices, is there's this notion of mutual trust, and it's not just a one-way street. The device has to trust the application has to trust the device, and so zero trust has to span both of those
That entire
worlds.
gambit of right,
That's right.
right. That
That's right.
that's really interesting.
Yeah.
Uh, you know, One of the things I've noted in talking to folks about IoT security in particular, but generally that notion of bringing zero trust into their environments as an operational principle, is that it's pretty daunting. I mean, it's not an easy thing to get your head wrapped around. Uh, Even the summary is kind of hard to get your head wrapped around, just much less the entire document. And then we've got this CISA rendition of the same thing and describing it in slightly different ways. I think part of the challenge that practitioners face out in the field is how do we get our organizations to think in terms of zero trust as a practice that they need to invest in and put time and effort into, and in particular in an environment where CISOs are hard to find. Security officers are not easy to hire, and they get hired away pretty quickly. You know, Organizations are really challenged, particularly those that CISA, for example, is designated as critical infrastructure, and therefore there is that expectation that they reach some level of compliance with zero trust requirements. What are some of the challenges that organizations face in trying to implement zero trust principles in their IoT environments?
It's a great question, and actually, this slide kind of hints to what those challenges are. So this is, as you pointed out, this is CISA's updated zero trust maturity model, which they just released, and it it draws upon those five pillars of zero trust. But what I think is important to look at is the maturity levels that they're designating, and so if you look at the traditional, which is I think where a lot of organizations still exist today, there's a whole lot of manual configuration and static management going on, and that's the challenge, right? Because you need to get um, to optimal, really, in an IoT world where things are fully automated and you have continuous assurance, right, where you're just constantly validating the right for a device or other asset to be there and to connect to your resources. So that I think shows the challenge is how do you get from traditional to optimal
Right, right,
when you have devices already out there in the field. You don't have enough humans to manually work on them. It's a challenge to kind of meet some of these requirements. Um, and I think a lot of people get stuck with this notion of certificate-based identity as a model, and they say, great, okay, we're using PKI, we have certificates that we're putting on these devices at manufacturing
right.
time, and we're covered. And that is a great foundation, but it's not the only challenge, right? You got to get beyond just PKI, because at some point those secure devices are going to start generating data, which is being used for actionable decision making, which is being used to feed AI models. And so, how are you protecting that data that's sitting on that device? We know, again, going back to that Verizon data breach report, one of the favorite targets of bad actors is unencrypted data sitting on devices, whether it's unencrypted keys, or other
Right.
other secrets, or unencrypted customer data. Could be medical data, could be consumer data like credit card information. There's all kinds of examples of companies who suffer that kind of breach and have like a ransomware attack. So how are you protecting the data actually sitting on the device? Certificates can help there, but you have to have a method for actually talking to the device. And
I think this recent data breach that's been in the news is a good example of where traditional approaches may not suffice going forward. So
yeah.
yeah,
Yeah, and another challenge is, if we acknowledge that identity is the new perimeter, right, as the foundation of zero trust, when those devices are outside of the firewall, um, how are you managing those identities over time at scale? That's a real challenge. So you have to have a
right,
way to do that. And then there's this thing that I talked about, which is mutual trust, right? So the application needs to have device trust so it can actually trust the data. And so when you're authenticating devices, it's got to be mutual authentication, so that there's two-way trust there. Um, another tough one that people usually don't think about in a zero trust world is, at some point you're going to find that there's a vulnerability, and that vulnerability needs to
right.
be patched or managed in a device. Now, if these are devices, again, that are remote and you can't send a technician with a thumb drive to go update the software or firmware, how are you going to patch those devices? You have to be able to do it over the air, and you have to be able to trust that you're sending signed code and things that are supposed to be there, and that device actually is supposed to get that. And all of these things together kind of make up this security lifecycle management challenge. How do you do all this centrally, again, at scale, which is the challenge we're talking about? Because only then really can you continually meet zero trust as a benchmark. And I think one of the toughest things is this last pillar, which is evolving legislation, because this is a moving target, right?
That's yeah,
I think everybody's familiar with the White House Executive Order 14028, which talks about zero trust. It talks about using software bill of materials, and then the EU Cyber Resilience Act, which would kind of use some of the same language. But now the SEC is coming out and saying, like, well, really, if you're a publicly traded company and you have a breach, you really need to publicly
yeah.
disclose that. You can't keep it quiet anymore. The FDA is saying, well, if you don't have an SBOM, then we really aren't going to accept your medical device. So there's all kinds of legislation and other rules coming out that are making this management even more difficult.
So Tyler, on that last piece, is it your sense that there there are capabilities, COTS, commercially off the shelf capabilities available that are going to create some pressure on organizations to really implement in the direction of meeting these executive order requirements? Is that your sense of the industry and where it's going? How closely can organizations meet the legislative requirements and the executive orders that are out there, and the CISA directives and DHS directives, NIST requirements or recommendations. What's your sense of where we are on that?
Yeah, I mean, I think all the pieces are there, and we as a sort of an identity security company for connected devices, we play a part in a bigger role. So we've always been in a position where we've had to really work closely with partners in the industry, and so we've had I think over the years and working with some of the largest organizations, global organizations in medical devices, in automotive manufacturing, in industrial manufacturing, and other sectors.
Right.
We've had a chance to work with a lot of those companies and understand from a client's perspective what really needs to take place to have this end-to-end IoT lifecycle managed. And so, over the years, we've developed our own framework, which we call the 9 core capabilities.
Right.
Some of these are leveraging our unique um, capabilities in the Keyscaler platform, but some of them are just having the ability to work with our partners' unique capabilities. And so I'll briefly go through these 9. I'm not going to go through in depth. There's actually, I think, for the viewers of this session, there is a document that I think is attached, which you can download, which is a 3-page sort of write up on the 9 core capabilities. It goes into a little bit more depth.
Great. Great.
But it really starts with the hardest thing, which is this notion of automated device provisioning. How do we take a device, secure device even, and integrate it into our operations, our security operations, our customer operations, right? Our environment. That first part is really, really hard because you have to validate that the device is who it says it is, that it's supposed to be there. You need to get it a set of credentials. You need to bring it into your environment, get it registered. And again, when we're talking at scale, these aren't things that you have armies of network security consultants that can do all this for you. So it needs to be automated. So having the ability to automate that initial device provisioning is a must. The next is PKI services for IoT. I think a lot of people are familiar with PKI, but PKI for IoT is a little bit different. How do you take a certificate-based identity model and apply that to devices and uniquely bind certificate to those devices? So that certificate belongs only with that one device. So again, going back to zero trust, you need to have very discrete ability to identify those things connecting to your resources. So one
Right.
certificate, one set of credentials can't be just universally applied to a class of device. They each need their own, and they all need to be mapped to the unique fingerprint of that device. Very difficult to do. Um, I talked a little bit about identity lifecycle management, and really the biggest challenge there is in a world where devices exist at the internet's edge. They're not always nicely connected and perfectly online. They could be in a remote factory. They could be on a remote pipeline. That could be offline at some, mining site, thousands of miles away. And you have to have a way to manage the identity lifecycle, even for that class of devices.
So on these first 3, if I understand it, it's really the capability to attach identities to devices, verify trustworthiness in a NIST sense, and to do that in a continuous way, because as you said earlier, I think devices come and go offline on some basis, and each time they come in, you've got to be able to validate them. Is that something that's really doable, or is that a challenge that's far off?
No, it's very doable. I mean, it's something that we do for our customers today, right? Because whether it's a device that is coming with secure credentials at the time of manufacturing, or if we're doing late binding of an identity to a device, so a device that doesn't have any credentials to speak of, and we actually have to apply them to that device that's already out there in the field, like a brownfield device, we can do that. And the challenge is, how do you then get that device provisioned into, say, Azure or AWS or whatever cloud platform you're using to manage that device? Very doable,
That
but
that that
it's tricky. And we've built a purpose-built platform to do exactly that. So yeah, it's doable. And similarly, applying PKI to IoT, right? Again,
right, right.
you need to have a purpose-built platform to do it, but those solutions do exist out there today. Yeah.
Yeah, I could just see all sorts of use cases where that
Yeah.
becomes a
Yeah.
critical piece.
Yeah, and then it continues, right? Because once you have the identities provisioned, and kind of in your operating environment, we talk about continuous assurance. So it's no longer a situation where you can say, yeah, we know it's a known good device, and we gave it its credentials, and we're just going to let it stay connected to the network for as long as it needs, right? Um, Really, what you need to be doing is constantly providing assurance that that device is trustworthy. So every time it's establishing a connection, you're revalidating its credentials. You're checking against things like, get to number 8, but like known CVEs that are out there in some
Right, right,
external threat intelligence platform, or with the White House executive order talking about SBOMs, right? So that gets to software supply chain risk, and understanding what's in your network. So, devices that are coming to you through multiple levels that have all kinds of software that's been compiled together and put together as a finished device. You need to have that software bill of materials to attest to what's in the device, and you need to constantly be validating. Are there any vulnerabilities associated with the software package, and
right,
does
right.
does this SBOM actually match up to the device that's claiming it should be here? So that is something that, again, you need to have the ability to do it, but the pieces are out there. Companies like Finite State do a fantastic job of creating very, very rich SBOMs, which we can then connect with and use that as part of the authentication process.
And just the sheer diversity and volume of devices that are out there, just the sheer number of them. This has got to be scalable, and if you're going to make continuous uh, assessments of trust every time a device comes in, so this is a really critical path piece here, I think.
Yeah, yeah, and the key is automation.
Right,
And then just kind of moving through the rest of these, things that make sense, right? We talked about data privacy and being able to, protect um, the data that's sitting on these devices based on policy, who gets to see it,
right,
uh, what applications get to use it. The secure updates piece, again, we work with one of our partners, Venafi, and some others, for being able to take a piece of code that's going to go into a device to update it, get that signed, and deliver that securely to the device. That's, again, you have to have the mechanism to do it, but it's out there. The other one is that, connecting with an HSM. I think, for those of you who don't know an HSM, it's a hardware security module. It's sort of the highest level of security for storing encryption keys and other secrets.
right, right.
And for those who are using them, HSMs were never really designed to have a device connecting directly to them. So we've
Okay,
developed an access controller module that allows you to securely allow devices to request keys and do other functions on the HSM itself, while still protecting the protected workloads in that HSM. I touched upon external threat intelligence, and that's you know looking at some of these third-party systems like Defender, like Sentinel-1, other threat intelligence platforms that are collecting all these signals. Our last presenter, Kayvon Karimi from Microsoft, was talking about how Microsoft collects trillions, not billions, trillions of threat signals on a daily basis, right? So being able to make use of those when we're authenticating a device is very, very powerful. And then the last one is this notion of continuous authorization. The session I had earlier with our CTO, James Penny, talked about how, you know, using the data that we're observing in a device and learning from it allows us to have this notion of continuous authorization, where it's not just a one-time event, We're always
Right, right.
asking. We're always asking the question: is this device behaving the way it's supposed to behave? Does this device look the way it's supposed to look? Are there things that we need to be looking out for that a human might not notice because everything looks all right, but a machine might sense a pattern that is, requires, a deeper look and might need a device to be quarantined for deeper
Right.
inspection. So these are all these 9 core capabilities we've learned through many, many years of working with our customers are things that need to be considered in an IoT or connected device ecosystem in order to really have a sustainable zero trust security approach for your devices.
And as we get into, just devices everywhere kind of ecosystem, doing it at scale and doing it in an automated way seems to be the only way you can get there. And so, in your mind, Tyler, how responsive are technologies that, including Keyscaler here, that are meant to uh, observe that there is a threat, learn about security vulnerabilities, and then implement against those threats in terms of response, going back to the NIST paradigm of being able to respond to the threat directly. Is that is that latency in response going down? What's that look like now?
Well, it's certainly. I think it's. Think about the right way to respond to the latency and response going down. I think it's allowing us to respond more quickly. So I'm kind of answering that in reverse.
No, that's fair.
Yeah, yeah,
That's fair.
yeah,
Yeah, yeah,
yeah,
yeah.
yeah. And I think, like, so in this next slide, this kind of shows you
Right,
when you take those 9 core capabilities and then again go back and look at this NIST cybersecurity framework. How does that now paint a complete picture for a customer? So thinking in terms of zero trust through this whole framework, it now allows us, with all the things I talked about, to generate a strong root of trust, which creates that foundation for zero trust over time, right? That strong identity that now allows you to know what it is that's trying to connect to you. You can now, because we're able to apply policy, zero trust policy to these devices that we've assigned an identity, it allows us to take our sort of IT security policy and apply it to our OT environment, something that never
right,
really
right.
happened before, right? I think it used to be that a CIO, CTO would worry about what was within the network, and then any of the OT stuff was, hey, that's the factory manager or that's someone out there in the supply chain, man. I don't worry about my OT, but not anymore. Right now, you need visibility across all of that. So, being able to apply zero trust policy out to these devices allows you to unify those two worlds. I talked a bunch about on the detect and respond piece about, you know, um, being able to leverage third-party threat assessments and that external threat intelligence. So that's essentially allowing us to take these rich threat intelligence platforms and extend this out to this new perimeter that is outside of the firewall. This new identity perimeter. The net result is really what you're going after in this framework, which is always assuming that there's going to be a breach, right? So how do
Right,
we
right.
respond? How do we respond, and how do we recover? And so the answer to your prior question is, is it bringing latency down? Well, the whole point is that when we apply automation and we start using these zero trust frameworks and automating that out to these devices, we can do things like very quickly improve our response time. We're no longer waiting for someone in a security operations center to notice a trend, see a blinking light, go and try to click it and mitigate that threat. We can now leverage AI, we can leverage policy to, the minute there's a threat detected, actually quarantine that device and not allow it to go and contaminate the rest of the network or contaminate your data that you're just feeding your AI. And ultimately, once you've mitigated that threat, how do I very, very quickly reduce my recovery time? In other words, get my supply chain back up and running into optimal order. And you need to be able to patch a vulnerability and renew credentials very, very quickly. And automation again saves the day here. So you can see, when you start thinking about zero trust in the context of this full cybersecurity framework, and then start applying automation and all of these 9 capabilities, you have a very rich, very complete approach to achieving zero trust in your connected device operations.
Very nice. I think I'm intrigued by the idea that by creating solutions that allow us to meet the NIST requirement uh, around zero trust for IoT devices opens the door to a lot of value-added capability. Often we think of security as a cost center, not a value-added activity, productive activity. But in this case, I think the lack of these tools in the marketplace and in practice have prevented us from really taking advantage of the technologies that are available in a meaningful way. So this sounds like a nice pathway to move forward. I was intrigued by your reference to AI and ML. At the end of the day, you've got an operator somewhere, and it's either a human or a device or an AI. And yeah, I like the icon because that's fits in my the Borg are coming kind of mentality. So help us understand where tools like Keyscaler can help us manage AI and IoT in a useful way, and maybe mitigate some of the things that people have been talking about as risk areas for AI.
Yeah, and I would encourage anybody that's really interested in the AI conversation, go back and view the session I did earlier with James Penny, our CTO, because we went into this in depth.
Yeah.
And I'm just sort of showing this model. This is our solution platform, but I think it's a good way to think about any technology provider, how you need to go forward to manage a device ecosystem, because you do have um, you know platform capabilities, your core platform capabilities that probably exist in the cloud, and Keyscaler's available, as a SaaS model or sort of a private cloud model. But then you always have these edge scenarios, right? So how are you managing those devices at the edge? And so we built Keyscaler Edge to help us take those
Right.
core Keyscaler central capabilities out to those devices at the edge. And then the third piece is this AI, right? So how are we leveraging the data that we're observing and collecting to be smarter about our overall management, right? To kind of act in a sort of a both an unsupervised and a supervised way. Because AI, I don't think it's never going to be where it's just let the machine go do its thing and you don't ever have to worry about it. I think there are some scenarios where, based on policy, you'll let your AI self defend, right? So Keyscaler hopefully gets to the point where it can defend itself from certain attacks. But there's also going to be situations where it needs to be supervised, where you need a human to make a judgment call as to whether
Right.
that was just an anomaly or is it a real attack, right? So you don't want to bring your entire supply chain down in certain circumstances without having somebody with sort of the professional judgment, the professional expertise to intervene at some point.
Nice. So that's not a neural chip, right? Is that if I understand
No,
it right? So
not
we
a
can
neural chip.
so we could treat humans as devices at some point. You've
That's
got
right.
a great. I love the slide. You've got a lot of partners here, and I think it would be interesting to learn a little more about how you work with partners, how you bring new capabilities into this domain of work with securing IoT devices.
Yeah, no, that's a great call out. So, as I mentioned earlier, partners are a big part of our go to market and critical to our and our customers' success. Here's an example of just some of them. It's a much bigger list, but these are the ones that we really, I think, either go very deeply with or have had a lot of experience with. Venafi, I mentioned, we have a partnership on the code signing side. And Trust, we do a lot around their PKI as a service and their core PKI services. Obviously, Microsoft is one of the technology leaders. They're one of our most strategic partners. We are
Okay.
tightly integrated with the Azure cloud, and particularly a lot of the IoT services that they provide, and similarly with customers like PTC ThingWorks and so forth. So we really we pride ourselves in being able to leverage existing investments that our customers have made either in cloud technologies, security technologies, or other, and easily connect to them. So the Keyscaler platform gives us a way to integrate with those services, whether it's a certificate authority for signing certificates for devices,
Right,
or
right,
whether it's
right.
a cloud platform for managing the devices themselves.
And it sounds like you've got what some would call an API gateway that allows people to plug and play. Once you find new technologies you need, you can add them into the mix pretty straightforwardly.
That's right. That's right. And that's what these service connectors indicate, where we've, kind of used our EPIC framework, which is the Enhanced Platform Integration Connector, to build out reusable connectors that become part of the platform. So every time we build one of these, it becomes an option in the Keyscaler platform that customers can, which cloud are you using, which certificate authority are you using, and eventually getting to things like with CyberArk, privileged access management, and so forth.
Excellent. Thank you.
Yeah.
Do you have other? We're on slide 11 and 12. What's on slide 12? I'm curious now.
I think slide
There
12 is
you
just a
go.
thank. It's
Thank you.
just a thank you. And so
Perfect.
that is the end. It's the end of our slides.
Yeah.
And we do have some time for Q&A. I do see a couple of questions here in the window,
Yep.
which I'll get to. And again, I would encourage anybody, if you're viewing this on demand, which we typically get a lot of on-demand viewers, you can still ask us questions. Put them at the info at address that you see below, or contact me directly. I'll be happy to answer any questions there. Question that I see in the window is, can you explain in more detail the SEC proposal requiring the member companies to address their cybersecurity risks? Great question. So I think a little bit over a year ago, the SEC had proposed a rule where they were going to make any brokerage, actually online brokerage, that was trading in securities that suffered a material cyber breach, disclose that publicly. And that was since extended to basically say, no, basically any publicly traded company really should, if they have a material cyber breach, they need to disclose what was the outcome of the breach, like what actually happened,
Okay.
who is responsible, like for the cybersecurity posture of the company, and who's responsible for mitigating the breach, who's actually going to go back and take care of that and notify and these have to be disclosed publicly. So you can no longer hide behind like a ransomware attack and just say, oh, there was a ransomware attack, but you don't actually disclose
What the?
what was. Yeah,
Right.
exactly.
Right. Uh, in terms of that kind of vulnerability analytics, does Keyscaler provide some capability to meet that requirement by the SEC, or is that you're really focused on preventing the problem in the first place?
Yeah, well, we're not in. I mean, we're not going to help them with the reporting aspect of it. I would like to think that for companies that operate connected devices, that Keyscaler could help them automate the protection and management of those devices, so the likelihood of a breach is minimized in the first place. It's
Right.
the way I would look at it. Yeah, that's the
Yeah,
way I would look at
it's all of those places that people don't think about that are vulnerable, including the refrigerator in the kitchen, in the kitchen, a coffee maker, and thermostats, etc. In addition to all of the key industrial control systems they may have in their environments.
That's right.
This has really been a wonderful session. Thank you, Tyler. Learned a bit. I don't see any other questions. If you have some closing comments, we'd appreciate it. But I think this has been informative. And I would invite the audience to join me tomorrow for my session with David Erie, CTO of the Virginia Innovation Partnership Corporation, to talk about the real challenge of deployment from the other side of the fence. From the perspective of organizations, is zero trust attainable for them? So hopefully you'll be able to join us for that. Some final thoughts there, Tyler?
Well, I think I was going to call out some of the future sessions. Certainly our first day here. our first day here, had a lot with regards to sort of automotive security, AI, and generally, protecting scaled out device ecosystems. I think that's going to continue tomorrow. I think the themes of responsible use of AI you'll continue to hear, and certainly zero trust. I mean, those are two overarching themes, and how that applies to sustainability in your supply chain. So I would say, just as a closing comment, thank you to everybody who was with us today, whether it was for one or multiple sessions. We look forward to seeing you tomorrow, and keep the questions and conversation coming. Thank you.
Thank you.